Dear students, greetings. In this video lecture, we are going to discuss about data link layer protocols. So, data link layer protocols means how the data flow happened in the data link layer based on the protocols. Okay. So, the data flow means whatever data we are sending from the sender side, the same data received by the receiver or not. That we have to ensure it. That is the flow control. Okay. So there is overflow is there or underflow is there, where the data loss is there, how we can ensure there is no data loss. Those things we will discuss in this lecture. This is classroom discussion topic actually. Data link layer protocols. As per our syllabus, there is two type of protocols are there: noisy channel protocols, noiseless channel protocols. Okay. So this topic is classroom discussion topic 17, data link layer protocol. Before going to discuss about this topic, we must know the outcome of this lecture. After listening to this video lecture, you as a student will be able to develop a new protocol based on the idea to be discussed in this lecture. Okay. So whatever the idea is there, we are going to discuss now. Based on the idea, you can develop a new protocol. So let us see how the data link layer can combine framing and flow control and error control to achieve the delivery of data from one node to another. So the data link layer is responsible for data control and flow control as well as access control. Okay. The protocol is normally implemented in software by using one of the common programming languages. Protocol means some rules and regulation. The rules and regulation may be implemented using some programming language. Okay. But here what we are going to do means we are not saying about any programming language, only we are discussing about the algorithm. Okay. The protocols of data link layer can be classified into for noiseless channel, for noisy channels. According to that, it is classified for noiseless channels. Simplest protocol and stop and wait protocol is there. For noisy channels, there is a stop and wait ARQ, go back NARQ, select to repeat ARQ models are there. Especially, we will concentrate more on noiseless channel protocol. Okay, so simplest protocol, stop and wait protocol. And another concept is piggybacking. We will discuss. Okay. This concept we will discuss while discussing this protocol. So first we will discuss about noiseless channel. What is noiseless channel? There is no disturbance. There is no noise. That is considered the noiseless channel. Okay. So in the channel, there is no frames lost or duplicated or corrupted. That is considered a noiseless channel. So in this protocol, we have two types of protocols are there: simplest protocol and stop and wait protocol. So what is simplest protocol? Simplest. Before going to discuss about the simplest protocol, the design of the simplest protocol, no flow or error control. Okay, so you just remember that just simple, whatever data we have, that we are forwarding it. That's all. There is no flow control, there is no error control. That's why we are saying simplest protocol. Okay, what it is there? The network there, it is getting the data link layer, getting and making the frames. That frames will send to physical layer. Okay. So these frames will be transmitted to receiver side physical layer. The frames will encapsulated or decapsulated, and it will identify the frames. The frames again decapsulated, and finally the datagram will be delivered to the network layer. Okay. So what are the things we are going to do? Event request from the network layer, because we need some packet to transmit to the data link layer. That event should be there. So repeat for our algorithm for sender side. What will be happen? That data link layer is always waiting for getting the data from data link layer. The receiver side again, it is providing, it is getting the data from physical layer, because receiver side it is getting from bits from physical layer. So any notification is coming or not, that will check from the physical layer. So these two events will be happened in the simplest protocol. Okay. So simply whatever I discussed, I given in the algorithm, you just see here. Center site algorithm. What is the center site algorithm? Wait for the event. First, initially, repeat forever while true. So wait for the event. Any event is occurred or not, it will check. Okay. Event request to send. Request to send means that event is ready to send the data. So what it will do? Get the data from network layer, make the frames, and send the frames to receiver side. That's all. This is the algorithm. Okay. So in the receiver side, what will be happen? Again, so receiver side, it is getting any event is there or not. That event is arrival notification. If any frames are coming from physical layer, it is waiting for that. If once the notification came, then what it will do? Receiving the frames from the physical layer, extract the data, then it will deliver to the network layer. Okay, so this is the simplest protocol. Okay, so this is the diagrammatic representation of simplest protocol. Okay. So sender is there. Initially, it will wait for request. If any request came from there, then simply sending the frames to the receiver side. Once it is arrived in the receiver, what are the event? Here request will be there. Here arrival will be there. There is no flow control and error control in the simplest protocol. So next we are going to discuss about stop and wait protocol. Okay. So what is stop and wait protocol? So in the previous simplest protocol, there is no um, flow control and error control. But here, there is a acknowledgement is there. Basically, acknowledgement frames will be attached for ensuring the flow control. Okay. So that things we have to remember this. So what is the meaning of stop and wait protocol? The sender sends one frame and stops until it receives confirmation from the receiver. That means the receiver says that I received the frame. You can send the next frame. Like that, it will give the OK message. Then only the sender will send the information. That is stop and wait protocol. Here, what are the events are there? First, request from network layer. It will request any data wants to send. Then after that, it will check continuously. Notification from the physical layer. Both it will be there because we are sending the data frame, we are receiving the acknowledgement. Both action will be there. Okay, for sending, we have to request the data from network layer. For receiving acknowledgement, we are getting the notification from the physical layer. But in the receiver side, what happen? Only it will send the acknowledgement, but when it will send, once it is received notification from physical layer, then the receiver side is receiving the notification. Accordingly, it will do the operation. So whatever we have discussed, like after getting the bits, it will be converted into frames. Then frames will be sent to network layer. Okay, so this is the operations of stop and wait protocol. So simply what happens, initially the request will comes to node center, then center will send the frames to here. Once arrived here, then receiver will send acknowledgement. So for this frame, in case frame 1 it is received means will send the acknowledgement 1. Okay, so once acknowledgement is reached here, then only the next frame will be transmitted from sender side. Okay, so then the receiver will send acknowledgement for second frame, then only the third frame will come. So like this, it will wait for acknowledgement and it will send the data. What is the drawback? Advantage is, yeah, flow control may be there. Okay, so flow control is there. What is flow control? Whatever data it is reached to destination or not, we are checking. Okay, so we are getting the acknowledgement means it is arrived properly. So if it is not getting acknowledgement, what happens? We have to resend the data. Okay, so that is a flow control is there. But what is the disadvantage of this method? We have to wait for acknowledgement also. If some time we have to wait, then after receiving acknowledgement only we are sending the data. So this entire time will be wasted. Okay, so this is the only disadvantage of stop and wait protocol. So here, two thing is there for sender side. One is for request to send, okay, or cancel the send, anything. So further, what it will do, get the data from network layer, make the frame, send the frame. Can send equal to false. That means if acknowledgement, can I send like that one message it will be there. It makes it a false, still getting the acknowledgement. Okay. So after sending the frame, will be make us a false. When it will be the true, once it is getting the acknowledgement, then it will be the true. Okay, so here arrival notification. Once acknowledgement is received, then can send will be true. So that means the next packet is ready to transmit. So this is the sender side. The receiver side just getting the frame and it will send the acknowledgement. So in noisy channel means some noises are there. Okay. So how to add flow control to its producer? Noiseless channels are non-existent. So these three protocols mainly used for noisy channels. Okay. So what are the protocols? Stop and wait protocol. Stop and wait automatic repeat request ARQ. Okay, you just remember automatic repeat request. Go back N selective repeat. So these three ARQ protocols are there. So how these protocols are working? Automatic repeat request. It will use the timers. Okay. So here, example, stop and wait protocol. Okay, you consider that stop and wait ARQ protocol. Okay, so if the node A is there, okay, so node B is there, what it will do? First, it will send the message frames, then it will send the acknowledgement. Okay, so this is acknowledgement, this is frames. So what happened here? Timer will be there. The timer will be allocated for this much time. Within this time, if the acknowledgement is received, then it will send the next packet. Okay. So in case acknowledgement is getting failure within the time it is not received. So what it will do? It will resend the same packet which is already sent. Okay. So for that, you have to maintain the duplicate packets which it is sent already. Okay. So once acknowledgement came, then the packet will be discarded. Then it will send the next packet. Okay. So automatically it will resend the packet when the time is expired. That is stop and wait ARQ protocol. So what is the disadvantage again? So same thing. It will wait for acknowledgement and until getting the acknowledgement, it is waiting to send the data. So that is the disadvantage of stop and wait protocol. Next one, go back and ARQ protocol. Okay, go back and ARQ protocol. What is that? So instead of getting acknowledgement, what it will do means it will send continuous data. Okay, so frame one, frame two, frame three, okay, frame four. So what happened after reaching it? It is also sending acknowledgement one, acknowledgement two, acknowledgement three, acknowledgement four. So like that, it will continuously send the data. Acknowledgement also receiving continuously. Whenever the acknowledgement is not received, so what happened? This is sender side, this is the receiver side. So whenever the acknowledgement is not getting, it is failure, then what it will do, wherever the failure is happened from that point, so from that point, it will resend the transmission. If example, it is sending 5 packets, okay. So it is received the 2 acknowledgement, third acknowledgement getting failure. What will be happen? Again, this will send from 3, 4, 5. Okay, so again, these 3 packets are resent. Okay, so that is the disadvantage. Advantage is no need to wait for acknowledgement. It continuously it is transmitting the data, but while the data loss happened, it will resend all the packets where the mistakes are happening. Okay, that is go back in ARQ. Here they are using one concept, the sliding window concept. So sliding window means it will frame the size. Accordingly, it will continuously sending the data. Okay. Once it is getting the acknowledgement, next frame will be there. So last, what is the disadvantage here? If in case 1,000 packets I transmitted, 1,000 frames we are transmitted, suddenly it is not getting 400th frame getting failure. That is acknowledgement is getting failure. What is the problem again? Again we have to send the packet from 401 to 1,000. Okay, resend is again we have to perform the more data we are transmitting. For that it will take more time. That is the disadvantage of go backend. So now we are going to discuss about selective repeat protocol. Selective repeat protocol. What is the meaning of that? So name itself is showing that selective repeat. So in the go backend, if failure is there, then it will send all the data. But in selective repeat, what happens? If sending the data like go backend, but in case any one of the acknowledgement is getting failure, if any one of the acknowledgement is getting failure, that particular frame only resend. That means selectively we have to resend the data for which acknowledgement is not received. The remaining are already is there. So, for example, same example, I sent 1,000 frames, but 400 frames are getting failure. But 401 to 1,000 there is no problem. Okay. So instead of that, I am resending only 400 frames. Okay. So that is selective repeat protocol. Clear. So now we are discussed noisy channel protocols and noiseless channel protocols. So that is a concept is there for piggybacking. What is piggybacking? Piggybacking means wherever the data acknowledgement is there, no, that is sent by letter. So immediately it is not sending acknowledgement, but whenever it is sending the data, it will send the acknowledgement with the data. That is piggybacking. Okay. So that means the sender will send the data, but acknowledgement will. So here both the direction data will be there. Here some frames will be there, frame 1, then it will send to frame 2 plus acknowledgement. Okay, acknowledgement of frame 1. So whenever it's sending acknowledgement with frames, that is considered as piggybacking. Okay. So now we are in end of this video lecture. So in this video lecture, you are understood what are the protocols are there and how the protocols are working. Based on this idea, you can develop the new protocol for data link layer. Okay. Thank you very much for listening this video lecture. The next video lecture we will discuss in next topic. Okay, thank you very much. So next classroom discussion topic is standard Ethernet CDT-18 that we will discuss in the next video. Okay, thank you very much for listening this video.